Hi everyone and welcome. Today we are going to be doing a lesson on box plots, also known as box and whisker plots. So you may remember these back from middle school, and you might recognize them as looking as though they have boxes and then two whiskers on the left and right hand side. So we're going to break these down to talk about the different components. So I'm going to be using my markup tool on Cami. I'm going to be using different types of highlighters to talk about the different components. So we're going to first start off with the lowest value, which is also known as the minimum. So we'll be using that interchangeably. Next up, we have Q1, which is also known as the first quartile. And I'll talk about that in just a moment after I talk about median. So next up, our third number that we'll be plotting in a box plot is the median. So median is going to be the middle number of any data set. Now going back to Q1, if we wanted to calculate Q1, it's going to be the middle number, so essentially the median, between the minimum and the median of the entire set of data. So it's kind of like the middle spot between those two. So now we have Q3, or third quartile, or sometimes upper quartile. And that's going to be the median between our median and the highest value, also known as the maximum value. And then if we ever have an outlier within our set of data, then we represent it using a dot. And as we'll go over in just a short moment, an outlier could be either to the left or to the right of data. So it could be either below all of your data, so much lower of a number, or it could be a much higher number. It basically just means that it doesn't belong. All right, so you might be wondering, well, what does this word quartile mean? And when you think of quartile, it sounds like quarter, or you can think of it as 1/4 or 25%. And so that's why we're going to mark this up so that we're representing each part of these as 25%. So between the minimum and Q1 is 25%, between Q1 and the median is 25%, and so on and so forth. And some of you might be wondering, well, why is it 25%, but one of them is super narrow and the other one is super wide? It's still the same amount of data, so it's still 25% of the data within that spot. It's just that it might be more varied and it might be a little bit more spread out. And that's why our graphs may look like that. So each of those are going to be 25%. All right, so let's go over some important formulas that we'll be using. Our first one is IQR, which stands for interquartile range. So when you hear the word range in general, you should be thinking of, all right, it's my general spread of going from my lowest to my highest value. In other words, the maximum minus the minimum. If we're talking about interquartile range, we're actually referring to the range between Q1 and Q3. So I'm going to label this as IQR. So again, that's just by calculating Q3 minus Q1, or in other words, the third quartile minus the first quartile. Now, the 5-number summary is the summary of numbers that allow us to create a box plot in general. So if we were drawing these by hand, which we won't be, we'll be using Staplet just as we have been before in our previous days. But if we were to draw this by hand, these are the 5 numbers that we had highlighted before that you need in order to create a box plot. And then we have the outlier test. So we have 2 formulas that we need in order to check to see if we have an outlier, because again, it could be either below or above the data set that we have. So we have either it's going to be below a certain number or above a certain number. So for instance, if we had a set of data that had numbers going from 0 to 100 roughly, but then we had a number that was all the way out to maybe 450, then that would be considered an outlier. But we can calculate it using these formulas. So the first one is Q1 minus 1.5 times the IQR. And then if a number falls below that number, then it's going to be considered an outlier. And then same thing if it falls above this one, Q3 plus 1.5 times IQR. And we'll do some practice problems with those so that they make a little bit more sense. All right, so attached to this video, you should have access to the Staplet app, which we've been using for our other graphs that we were doing a few days ago. So I'm going to go to my select tool, and I have the website opened already. So I'm just going to go over and copy all of these, and I'm going to paste them in. And this is just a random example, so I don't need a title or anything. I'm going to do begin analysis, and it comes out as a dot plot. I want to change it to a box plot. And look at that, we already have a picture, so I'm going to get out my snipping tool, and I'm going to snip my image, paste it in here because I like to have a reference and I like to have a visual diagram. And then you'll notice I'm asking for some important information. Well, they do give you some information here, so I'm going to snip the summary statistics so that I have them for myself here. And you'll notice they give me the 5 number summary right here. So I'm going to highlight that for you. My 5 number summary is right here. So the minimum, Q1, median, Q3, and the maximum are all there. These extra ones, this stands for how many numbers there were in total within the set of data, what the average is, and the standard deviation. We'll talk about standard deviation in a different chapter, but just so that you're aware. So now let's fill in all of this information. So we have Q1 is 4, Q3 is 12, the IQR is just like above here, Q3 minus Q1, so I'm going to do 12 minus 4, which gives me 8. So that means my box area here, the range here is going to be 8. And now I want to do my outlier test, and I want to see, is there going to be anything that is going to be an outlier? And based off my graph, it already told me that there is an outlier. It should be this number here, which in this case is going to be 32. But we're going to test that out to see if the website was correct. So we're going to do Q1, which was 4, minus 1.5 times the IQR, which was 8. So in the end, you should be getting a negative 8. So our outlier test here, for a number below, it said if it's below, in this case, a negative 8, then we have an outlier. Now our lowest number was a 0, so that's not below a negative 8. So in that case, we don't have any outliers to the left of our graph. So now let's test it out for above. we're going to be doing Q3, which is 12, plus 1.5 times the IQR, which was 8. And in the end, you get 24. So now the outlier test tells me if I have anything above a 24, that's going to be considered an outlier. So if you had 25 and up, those would be considered outliers. So I do, in fact, have a 32. That is most definitely above a 24, which is why this is my outlier. So then we can put 24, oh, I'm sorry, not 24. We can put 32 as our outlier. All right, so prior to this lesson, you learned about skewness and modality. So we can talk about a box plot being skewed either to the right or to the left, or being symmetric by looking at the tail. And by the tail, we mean looking at the whiskers. So here I can look at my whisker here being much longer on the right-hand side, which is why this graph would be skewed to the right. Now, my second one, it's roughly the same on both sides. Doesn't have to be exactly perfect, but more or less, as long as you don't see any sort of drastic differences, then we can say that's symmetric. And then for our last one, our tail is much larger and longer on the left-hand side, so that's why this one is considered skewed left. So we're going to do just one more example. We'll have you try it. So pause the video, try out doing the exact same thing that we did up here in the previous example. So put all of these sets of data within Staplet, figure out what the 5-number summary is, so you can snip the graph of it and replace it here along with the 5-number summary, and then try figuring out if there are any sort of outliers and if the data is skewed at all. And then after you finish it, then you can move on and check your work. All right, everybody, so hopefully you were able to calculate all of the numbers and figure out the outliers and the skewness. So using the 5-number summary, you were able to get all the way from the min to the max. IQR should have been 27 minus 18, which gives you 9. Then the outlier test shows you that if you have any numbers below 4.5, which we don't because the lowest number is a 13, or if you have any numbers above a 40.5, which we don't because our highest number is a 32, then we would have outliers. But since we don't have any numbers that fall below or above these, then we don't have any. And then looking at our tails, they are more or less the same. So we would say that this is a symmetric box plot. All right, everybody. Hope you're having a good day.